All right, the last naming on arcane. Okay, I think with these few examples, you should be able to name compounds, arcane compounds. So right now, the last one, number 7. Look at these now. You have 4 chloro groups. Okay, you have 4 chloro groups. Okay, so they are in position 1, 1, 2, 2. So we'll name it 1, 1, 2, 2. Tetra stands for 4, right? Tetrachloroethane. Et, 2 carbon atoms. Tetrachloroethane. Okay. All right, naming of alkenes. All right, we're through with naming of alkenes. Quickly, let's go to naming of alkenes. All right, the same pattern, the same method we use the naming alkenes. We're going to apply that same approach in naming alkenes. All right, only a slight change. I think we're having only a slight change in the naming of the compounds. Only a slight change in the naming of the compound. All right. Now let's see. The rule 1 says the parent compound is gotten by locating the longest branch chain. This gives the root name as we did in the arcane naming. All right. Number 2. Now let's see that example now. The position. Now you're counting either from front to the back or the back to the front would depend on the position of the double bond. Don't forget that alkenes are they have double bonds. They have double bonds. They have double bonds. All right. So your numbering now, either from the front to the back or from the back to the front, will depend on the location and the position of the double bond. Okay, now look at that example now. Put 1 in. Look at it now. You have to give the smallest possible number to the carbon atom after the double bond, after or before the double bond. That means you're having a carbon atom before the double bond, you're having a carbon atom after the double bond. Okay, now look at that first one. Put 1 in. We went from the back to the front. 4, 1, 2, 3, 4. 4, 3, 2, 1. Okay, now see. Put 1 in. Can you see? Not put 2 in. Because you have only 1 carbon after the double bond. After the double bond. Can you see? After the double bond, how many carbon atoms do you have? 1. Can you see? That is the reason why we can only go from back to front. If you go from front to back, you have 1, 2, 3, 4. Can you see? 4 is higher than 1. So the carbon atom after the double bond must be given the smallest possible number. That is why we have put 1 in, not put 4 in. All right. The double bond will carry the lowest possible number, 1, not 4. The second one also, you have 1, 2, 3, 4. Put 2 in. You have 2 carbon atoms before the bond. Okay, the principle is this. Have the lowest number of carbon atoms. Sorry, have the let the carbon atoms either before the double bond or after the double bond carry the lowest possible number. So you can either go from front to back or back to front, provided that the carbon atom, all right, before or after the double bond carry the lowest possible number. Look at the second example. You have 2. The carbon atom has number 2. If you go from back to front, you still have 1, 2. The one before the bond also have 2. Can you see? So whether the carbon atom is before the double bond or after the double bond, make sure it has just 2. Make sure it has the lowest possible number. Pardon me. Make sure it has the lowest possible number. So you have 2, put 2 in. Look at that one that has 2 methyl paint 1 in. Can you see? You have, if I go from front to back, I'll be having 1, 2, 3, 4, 5. Can you see? If I go from back to front, I'll be having 1. Can you see? 1. Can you see? 1 after the double bond. 1. That's the reason why we have paint 1 in, not paint 5 in, and not paint 2 in. Paint 1 in. 2 methyl is the attachment. 2 methyl. So you have to consider the position of the double bond first before considering the position of the attachment. Double bond first. So if I'm going from back to front, and that will give the lowest number to my double bond, then that's the pattern I'm going to go. And also going to name the attachments to the carbon atom. So you have 1 in, then 2. The position of the double bond is 2. If I go from front to back, I'm having 1, 2, 3, 4, 5. Can you see? That's a larger number compared to 1 and 2. So you have 2 methyl, 1 pent, 2 methyl, pent 1 in, or 2 methyl pent in, 2 methyl pent 1 in. Look at the other one, 3, 4 dimethyl pent 2 in. So the examples are very, very explanatory. Very, very explanatory. Quickly, before we round up the naming on alkenes, let's look at demonstrable examples of alkenes. Demonstrable examples of alkenes. Now look at that. The answer to the first one, number 1, is trans 2,3-dimethyl but 2 in. Why are we using trans? I've explained trans when I talked about isomerism. All right, trans. I've told us we use trans. You can refer to I think to that slide in your notes, okay, on trans and cis. I told us one, when the carbon atoms are transversal or vertically opposite to each other, and when they are, okay, parallel to each other. Okay, so we have trans 2, 3. Look at it. If you go front to back, you have 1, 2, 3, 4. If you go back to front, you also have 1, 2, 3. But the carbon atom now will have 3 instead of 2. If we go from front to back, that's the reason why we pick 2 as a lower number. 2 trans 2, 3 dimethyl but 2 in. Trans 2, 3 dimethyl. I think there's a mistake on that structure. The other methyl group ought to be on the 3rd carbon atom. I think there's a mistake in the drawing of that structure. So it should be CH3, then you have C, then attached to a methyl group, then you have double bond, you have another C, attached to the 2nd methyl group, then you have CH3. I think it's a mistake in the drawing of that diagram. Then number 2, you have cis. Cis is when the methyl groups are parallel to each other, while trans is when the methyl groups are transversal or vertically opposite to each other. You have cis 2, 3. I think, yes, is that same structure, the one that ought to be present in the number 1. I think it's a mistake. Okay, so you have cis 2, 3 dimethyl but 2 in. Okay, quickly, the last one, you see this one, 2, 3 dimethyl but 2 in. Let's go through the namings. Anyone giving us issues, please do let me know. All right, appropriate answers will be provided. All right, then the 4th one, you have 3, 3 dimethyl but 1 in. Then 4, 4 dimethyl pent 2 in. The major issue is knowing where to knowing the lowest possible number to give to the carbon atom, either before the double bond or after the double bond. So go through. Anyone still giving you issues, more exercises will be sent to the group so that we can attempt ourselves to name other compounds. Thank you very much.